Hello everyone, today we're going to be taking a look at the Hematocrit experiment in the membrane transport lab activity. And to take a look at what we have here really quickly, we have 7 different solutions. These solutions will include 2 milliliters of blood each, and then 5 milliliters of their respective solutions. Those will include distilled water, 100 millimolar sodium chloride, 150 millimolar sodium chloride, 300 millimolar sodium chloride, 300 millimolar sucrose, 300 millimolar urea, and then 300 millimolar ethylene glycol. Depending on the different types of solutes, as well as the different concentrations, we're going to see that they will interact with the red blood cells differently, like due to their different osmolarity, due to their different permeabilities, and their different properties at least. So the first thing that we need to do though, in order to start this experiment, is to make a hematocrit. So a hematocrit is going to be taking a look at the total volume of blood and then looking at specifically the volume of the red blood cells, or the packed red blood cells. So what we're going to do is take one of these small capillary tubes that you can see right here. These are these small tubes that will allow me to suck up blood into the tube, like using capillary action, and then centrifuge it to see, or to pack it all down and condense it to see the packed red blood cell volume. So to do this, it is a little bit tricky from this angle, but what you'll want to do is take the blood and take your capillary tube, try to keep the capillary tube as flat as possible so that you can allow the blood to enter without the force of gravity kind of going against you. We'll mix it up just a little bit to make sure that it's well combined, and then put the tip of the capillary tube in and allow the blood to kind of come up into the tube. What you should be able to see is that the blood is going to be coming up into the tube, and it's going to be going up, up, up. It will slow down a little bit because it doesn't want to go up that much, but you kind of have to maneuver it a little bit, and keeping the capillary tube relatively flat, it will continue to go up into the tube. Now you'll want to do this until you have at least 2/3, but preferably like 3/4 of it full, because the longer or the more blood that you have here, like the longer it will be, and that's what we're going to be measuring. We're going to be measuring the length of the red blood cells as well as the length of the entire volume of blood to see its proportion. So we're not measuring the volume really, we're measuring the percentage, the proportion of red blood cells to the total volume of blood. So I'm trying to get a good example here, so let's keep going just a little bit more. In some solutions it'll work a little bit better than others, but there we go. That's looking pretty good. Now once you have that at the correct, or as much as you want at the very least, what you should see here is that it's pretty full. But when you do this, or when you make a capillary tube, you want to hold at least one side so that it doesn't fall out. So similar to how you had a straw, like when you pick up soda using, I don't know, a cup, this is the same type of thing. But now what we're going to do is press it into this cryptoseal in order for it to close up one side so that when you centrifuge it, it doesn't like spray everywhere essentially. So you'll carefully support the bottom as well as the top, and then press it in, and hopefully you'll see that there's a white plug at the bottom. If you have that white plug, you're pretty much good to go. So this is going to be one capillary tube of one sample of blood. I'm going to do this for all 7 of these bloods, and then we're going to centrifuge it in order for it to pack it down, and so that you can see the difference in volume between the red blood cells and then the total blood volume as well. So we'll get to that in the next video. Good luck, and see you later.